Hello and welcome back. Section 2.2, we're going to go over the graph of a function. So recall from the last section, a relation is a function if for every input there is a unique output. Now, with graphs, there are ways to tell that even if they don't give us a nice mapping diagram like we had in 2.1. If they just give us a two-dimensional plane, generally the horizontal is considered your input variable and the vertical your output variable. So x and y, or sometimes the input might be time t and different outputs. Excuse me. But even though we have an uncountably infinite number of points on that curve that I just sketched, every single input value corresponds to only one output value. So any input that I go to, I can find exactly one number for its output. So this one is both a relation and a function. We'll keep the same convention. Input is horizontal, output is vertical. Again, we qualify to call this not just a relation but also a function. Anytime I pick an input value, I can find a corresponding point on my graph that has exactly one output value. This is another example of a relation. This one, however, is not a function. At this input value, we'll call this C. We have actually 3, but all I need to show is 2. As soon as you can find me one input with more than one output, so C corresponds to both A and B, it's no longer a function. And there's kind of a shortcut way we can do that, and that's the vertical line test. And the idea behind the vertical line test is you have to have the ability to drop a vertical line anywhere on your graph and hit the graph only once. If we can do that, we have a function. If there's anywhere at all that I can draw a vertical line and touch the graph twice, it might be a relation, but it is not a function. So my first two, no matter where I drop a vertical line, I will only touch that graph one time. Same thing with the second one, I can only touch it one time no matter where I drop my vertical line. The other two that are relations but not functions, I can draw a vertical line and hit it 2 or more times, not a function anymore. So the next thing we look at is gathering information from the graph of a function. So the last 4 were done without scales or without any ordered pairs. Sometimes they will give us a little bit more information on a graph. And as long as I have the ruler here, might as well make a prettier graph. So here I'm just putting a scale on the horizontal axis, and I already have one set up on the vertical axis, and I'm going to just put together a curve. And I'll just go ahead and connect these with sort of a smooth curve. And I'm not going to put arrows on the end. I'm going to assume that this is the entire thing of our graph. This is it. And there's several things they can ask us to find. So first of all, this does pass the vertical line test, so this is a function, and we'll name this function f. So the first thing that we'll look for is just sort of a handful of points. So we'll find f of 0, f of 5 pi over 2, and f of 7 pi over 2. So with the notation, f is just telling me the name of the function, and this is telling me the input value, the x value if you want to think of it that way, and it's asking me then what y value matches up to that. Well, when x is 0, it looks like in this case y is 0. So this is equivalent to saying we have the order pair 0, 0. F of 5 pi over 2. So again, it's telling me go to the 5 pi over 2 on the input and find the graph and tell me what the output is that matches it. The output matching it is a positive 1. So f of 5 pi over 2 is 1. That's also equivalent to saying that 5 pi over 2 comma 1 is an ordered pair on the graph. F of 7 pi over 2, same idea. Go to 7 pi over 2, find your graph, find the output value, in this case a negative 1. The domain of a function, that is the set of input values we can use. On this, I've put just solid filled in points on the ends and not arrows, so I'm not saying this keeps going. So as far left as I can go is 0. As far right as I can go to 4 pi. That's if we go with interval notation. We also have set builder available. Set builder would be set of all x such that x is in the set of real numbers, and 0 is less than or equal to x, which is also less than or equal to 4 pi. The range is another common topic when we're talking about functions. Range is just talking about the same idea, but output values instead of input values. How low can you go? How high can you go? We can go as low as -1 and we do reach that point. We can go as high as +1. We can also reach that point. If you want the set builder notation instead, set of all y such that y is in the set of real numbers, and -1 is less than or equal to y, which is in turn less than or equal to +1. Finding intercepts from a graph, those are pretty straightforward. Where does it touch the x-axis or the y-axis? X-intercepts, and we've worked with those before. Looks like we touch at 0, 0. We touch the x-axis again at pi, which means we have 0 for the y for touching the x-axis. We touch again at 2 pi. We touch again at 3 pi. And we touch again at 4 pi. Use my little early parenthesis there. Y-intercept, I know automatically that's going to be a singular, not y-intercepts, if we're working with a function. If we have more than one y-intercept, then we fail the vertical line test and we are not working with a function. We only have one y-intercept, and that's the origin. They may ask us how this graph relates to another equation. So they may ask us for a number of intercepts. How many times does f intersect y equals 1/2? Well, the graph of y equals 1/2, I'll do that in red, and I'll just kind of put a dotted line on there. So here's y equals 1/2, so here's one spot, 2, 3, 4, 4 places. We know the y values of those. We don't know the exact x values without more information. May ask us to find all x. ST is common abbreviation in math for such that f of x is equal to 0. Now you might think we looked at something pretty similar to that already. They already asked us for f of 0. Well, notice the 0 is in a different spot. Before, the 0 was inside the parentheses, and they were telling us the x is 0 and asking us what is the y. When they say f of x is equal to something, they're telling you, okay, I'm giving you the output value. I'm giving you the output. What input or inputs match up with that? Well, those you might recognize. Y value and output of 0, those are the x-intercepts. So those happen when x is equal to 0. It also happens when x is equal to pi. It also happens when x is 3 pi. Skipped over 2 pi, my apologies. 2 pi, 3 pi, and it also happens at 4 pi. So just watch out for where the value they give you is. Is it inside the parentheses, in which case they're giving you an input? They're giving you an x. Or is it outside, in which case they're giving you a y and asking you to find x's? And then the last one, we'll kind of flip back to this in just a second. For what values of x is f of x greater than 0? F of x, remember, that's sort of our output, our quote-unquote y value. Y greater than 0, that just means that y is positive, in other words, above the x-axis. So if we go back to our drawing, everything to the right of 0, but still to the left of pi, is above 0. So one interval we have is 0 to pi, and I'm making that an open interval because they said strictly greater than 0. If they said or equals, I would have closed brackets instead of open parentheses. And I'll union that up with the next part. So we hit the axis, we dip below it, we hit the axis again, then everything after 2 pi but before 3 pi is above the axis. In other words, positive outputs. So we'll union that up with 2 pi to 3 pi. After that, we dip below the axis again and just reach it at 4 pi. Now, if they said hypothetically, same question, but f of x is greater than or equal to 0, as I mentioned, closed on 0 to pi, closed on 2 pi to 3 pi, and then we would have to union that up with the single point of 4 pi. Not an interval, but we just sort of reach it and stop. Just something you would run into once in a while. Alright, so that's a little bit of what we can do with analyzing the graph of a function. So next up, we look at what we can do when they actually give us an equation for a function. So we'll look at f of x is equal to difference of x and 5 over sum of x and 2. So we'll start with the domain. So here, when they're giving me an actual equation, I'm looking for, okay, what would make me break a rule? If x is -2, I'm breaking the division by 0 rule. Division by 0 is undefined. So my domain, I have to kick out the -2, so I can keep anything from -infinity up to but not including -2, and I tell the reader that with a parenthesis, and I'll union that up with -2 approaching infinity. So if they want interval notation, that's how to do the interval. If they want set builder notation instead, set of all x such that x is in the set of real numbers and x is not equal to -2. And we just close that on up. They may ask us if a certain point is on the graph of the given function. Well, really we can find that out with substitution. 4/3 replaces the output f of x. Our equal sign gets a little question mark above it since we don't know if it's true or not. And all of our x's get replaced with 1s. So 4/3 possibly equal to -4/3. That is not. So this one is a no. If we get a true statement, then yes, it's a point on the function. They might say if x equals 2, find f of x. Basically, then what they're saying is they want us to find f of 2. So they're saying use function f, plug in a 2 everywhere you used to have an x. So 2 minus 5 over 2 plus 2. So f of 2 is negative 3/4. Let me flip over here for the rest of it. We'll put the function back up here just so we don't lose track. So this is still working with f of x is difference of x and 5 over sum of x and 2. That may ask us to find all intercepts. That is number one more before the intercepts. My apologies. I want to do one more. If f of x is 2, what is x? So this time 2 is no longer an input, 2 is an output. 2 equals x minus 5 over x plus 2. And then we're just solving that rational equation. We know x can't be negative 2. We'll multiply by our LCD to clear the fraction. So 2x plus 4 is worth x minus 5. So 2x minus x is x. Negative 5 minus 4 is negative 9. So this is happening at negative 9, 2. So then they also may ask us to find all intercepts. X-intercepts only happen when y, or in this case f of x, is 0. So 0 is x minus 5 over x plus 2. We clear the fraction by multiplying both sides by the LCD. 0 times anything is 0. So x equals 5. So 5, 0 is our only x-intercept. Y-intercept, that only happens when x is 0, so that would be looking for f of 0. F of 0, 0 minus 5 over 0 plus 2. So f of 0 is negative 5/2. So 0, negative 2.5 is our y-intercept. Alright, so our last one, we're going to do sort of a rare problem where we're doing some decimal approximations. Typically I want exact values, but this next one they do have us working a little bit with decimal approximations. Average costs per day to make X whatever thing, I said widgets, just whatever arbitrary thing we're making each day. This is one sort of business example where they would use functions. So C bar of X for this one is going to be 49 hundredths of X squared minus 29 and 46 hundredths of x plus 964 and 53 hundredths plus 18,000 divided by x. So we'll start with finding the average cost to make 30 per day. That would be C bar of 30. And we just plug in 30s everywhere we had X's before. So again, this being one of our rare problems where we're looking more for just a decimal approximation. 30 I'm going to store as my X. So the store button that's right above your on-off key, 30 stores X. Now every time I hit X, the calculator is thinking the number 30. So 0.49 X squared minus 29 and 46/100 X plus 964 and 53/100 plus 18,000 divided by X. Hit enter. And we'll round that to the nearest penny. So C bar of 30, 1121, 1121 and 73/100. So that means if we're making 30 a day, our average cost is 1121.73 per unit. So then we'll look at 40 per day. So same setup, but 40 per day. So C bar of 40, 49/100 by 40 squared minus 29 and 46/100 by 40 plus 964 and 53/100 plus 18,000 over 40. The nice thing about the storage feature on your calculator, if I want 40 to be the new X, 40 store as X, hit enter. If I don't want to rekey all that stuff, second an entry. Entry is right at the bottom right corner there. Second entry again, and that'll bring you back to the last thing you keyed in. Hit enter. There's our new value. So C bar of 40 is worth 1,020.13. That should make sense as we start making more up to a point. The cost per unit would decrease. So now our average cost is $1,020.13 per unit at 40 units a day. Now they may ask us how to minimize the cost. That is something that we can do with our calculators. That's another nice feature. So we'll go to our y equals. I'm going to clear out any old functions I've got in here. And we'll just key this in. I'm going to do it kind of off to the side here just so I can read it a little bit faster. 49/100 X squared minus 29 and 46/100 X plus 964 and 53/100 plus 18,000 divided by X. Now, obviously Zoom 6 isn't really going to help us. Zoom 6, we have -10 to 10, and we're putting in values like 30 and 40 and getting output values in the thousands. So we can go to our table for help. So we'll do the table setup, second and above your window there. We'll start at 0, and we'll change by, this time, 10 each time. Delta table to 10. Independent we'll set to auto. Then we'll go into table, and it'll create a table where we have 0 is error, since we have the division by 0 in the original. So 10 units a day, it's going to run about $2,500 per unit. And it looks like at 50 units, our cost went back up. Now we're at $1,076 per unit instead of $1,020 per unit. So our minimum is going to be somewhere in there. So it looks like 0 to 50 would be sufficient for our X's. For the Y's, I would say 0 to maybe 1,500 should be sufficient. 0 to 50, we'll count by 10, X scale of 10. 0 to 1,500, and we'll count by, let's say 100 and a crack. So here comes our curve, and we want to figure out the lowest point on that curve. So second and calculate again. Now instead of looking for a 0 or a point of intersection, we want a minimum. We want to minimize our cost. Left bound, just like before, it looks like our minimum is somewhere right in here. So I'm going to go to the right until my cursor is kind of close but not at the bottom. Right bound. Okay, it looks like my values for Y are popping back up. That's far enough then. And I guess looks like it's bottoming out somewhere around there. It'll think for a minute. So our X value, 40.99, we can't make 40.99 units, so we'll go ahead and say that our minimum average cost is, and this is in dollars, dollar signs go in front of the number, not behind. I don't know why I've seen that crop up in the last few years. Dollars go in front, not behind. So $1,019.38 per unit. At a rate of 41 units per day. So that's just sort of a nice application problem of the functions, and some more idea of some of the nice tools here a calculator has kind of built into it. All right, so some problems to try out from 2-2. I would try out 1 through 12 all, 13 to 43 odd, or the equivalent on my math lab. If you have questions, get in touch with me. Otherwise, I will see you next time.